Hi, class. Based on sort of the discussion that we had last week, I felt it would be good to have a supplemental lecture on statistical significance. Uh, so what we're going to do today is I'm just going to briefly go over a few facts about probability and other relevant features that I think are going to be useful to you in your careers. And we'll have a second lecture where we do this a little bit more rigorously with SPSS data. But the things I want us to cover are, we've had a few questions of what probability distributions are, what significance testing is, and we'll also get into linear regression and logistic regression. Those are going to be our final goals for this course, and that's ultimately what we're going to be working towards. The first thing that I want to go over is just the types of data that you might want to do significance testing with. And typically, data breaks down under these two categories that we have: numerical data and categorical data. Numerical data are things that ultimately are associated with numbers. So they can be things like a patient's temperature, how many times they've been hospitalized, and sort of they then break down into these two discrete categories of continuous and discrete types of data. We'll get into that a little bit more later. And we also have categorical data. That might be something like what a patient was coded as. These are things like gender, or potentially what symptoms an individual has. Do they have high blood pressure? Do they have a history of diabetes, for instance? And what we'll do is we'll look at how we can evaluate whether or not there are significant relationships across these types of data. So the first thing I want you to learn is, what is a probability distribution? Now, I'm borrowing this actually from my course instructor, a guy by the name of Christopher Barr, who is a wonderful statistician and is now a hedge fund manager. But the three sort of most important points that you should know about probability distributions are that that probability is a greater than the two main takeaways that I want you to have in terms of your informal understanding of probability is that events that occur in the real world must have a probability between 0 and 1, and that the sum of these probabilities must be equal to 1. So, for instance, a roll of a die, each side of a die has a 1/6 probability of turning up a particular side. And when you sum them up, they equal to 1. Conversely, something like flipping a coin, that also has two possible outcomes, each with a probability of a half, of heads or tails, and that also sums to 1. So those are examples of things that I would call a discrete distribution. And discrete distributions, again, the sort of key things you should know about them is that they take on finitely many values, meaning that they're small, relatively small, and that they're countable. The other thing that's important to know about them is that they have what I call mass, that they have weight associated with each specific value. So for instance, if we were to take two dies and throw them and then sort of count their total, that we would get something that looks kind of like this. That we would get these types of probabilities. And you see that for each value, there's an associated probability weight. So for instance, getting a 7 when you roll two dies is the most likely outcome. That occurs in a total of 6 out of 36 possibilities. And just to provide a visual of that, we can see why this occurs, that there are just more possible ways to get 7 when you throw two dice than, say, to get 2 or to get 12. And so these things sort of occur naturally. And the other type of distribution that I want you to know about is a continuous distribution. And there, instead of probability having mass associated with a particular value, it has what's called density. And what that means is that effectively, if I ask you, what is the probability that a random sample of the data has exactly a particular value? So for instance, if I ask what's the likelihood that an individual has exactly 185.3214 centimeters in height, the probability of that is always going to be 0. And that's just because we're choosing a very narrow and finite point. So what we tend to do instead is express continuous probabilities in terms of inequalities. So for instance, what range of, what percentage of individuals have, say, height greater than, say, 6 feet? That is an example of how I might want to express something in a continuous distribution. And again, one of the things that I want to emphasize here is that that the definition of a discrete random variable and a continuous random variable is actually a little bit fuzzy in and of itself. That we have here height bucketed into, say, very large bins, and you can see that that looks much more like a discrete probability distribution. But as we start to use narrower and narrow definitions, that becomes almost a smooth curve, and that slowly begins to resemble more and more like a continuous distribution. And in fact, one of the things that I like to joke about is that, in fact, almost all representations of continuous distributions in mathematics and statistics are actually discrete distributions, in the fact that computers and machines can only store numbers in discrete formats. So in fact, even when we are working with a continuous distribution in SPSS, we are often working with a discrete approximation of it. And for instance, what we're doing, one of the things that you can imagine us doing is trying to ask a question about what percentage of individuals fall within a certain height range. And this is how we would calculate it, is we look at the associated probabilities and densities for 180 centimeters in height and 185 centimeters in height. And what we would do is we would use a computer to look at the area under this curve, and that would return us a number that we know is going to be somewhere between 0 and 1, because we know that this is a probability distribution function.